devices. Right? And I'm not sure, have we done that configuration backup thing? Yeah, I think we've done it. It was. Today we'll see how to run config commands. Most of that is where the crux of the thing lies. Maybe Ramesh can go back on. Okay, I can do it. So this is where the real power of Ansible comes into picture, where we can write playbooks to do the configuration on remote devices. So let there be any number of devices, let them be anywhere in the geographic location, right? You can, as long as you have SSH connectivity, you can use Ansible to configure those devices remotely, right? In a consistent, repeatable manner. Because you have automated this task in a playbook. In playbook, you have specified what is the configuration that should be there on the network devices. So Ansible playbooks also work as a documentation because they contain the expected configuration that is supposed to be there on the network devices, right? Certain routers should have certain kind of BGP configuration setup, certain OSPF configuration setup. What should be the VLANs that should be existing on them? What should be the IP addresses that should be configured for different interfaces? Are there any loopback interfaces that need to be configured? All these are the decisions that need to be taken by the network architect. So once they take this decision, the playbooks can be created, and these playbooks will act as this is the expected configuration. Right? Then those playbooks will be stored in a secure locations like your software version control management systems, and at any point of time we can refer to them as okay. This is the configuration that is supposed to be on the devices. And when we run these playbooks, when we take these playbooks and execute them on the devices, right? The devices will be put into the exact state, which is mentioned in the playbooks. And playbooks, whatever state is mentioned in the playbooks, if the device is already in that state, then it will not be done. Then the task will not be carried out. If the proposed configuration, which is there in the playbook, is missing on a particular device, then the device will be put into that state, right? Suppose, let's say there are two devices. Let's take just two, for instance, on which we want to do certain configuration. But on one, someone has already gone ahead and done some configuration manually. Then when we take this playbook and run against both these devices, it detects that in device 1, the configuration which it is trying to do, like adding SNMP strings or creating certain VLANs, they're already there. They're already present on that device. Then Ansible will not do anything because what Ansible contains is the expected configuration, right? And the expected configuration is already present on the devices, so it will not do anything. But on the other device, the configuration is not there. So it will go and change the settings, change the second router to have the expected configuration. So this nature of Ansible is known as idempotency, which means you can run a playbook any number of times. It will not cause any ill effect, right? If there is something to be done, it will do. Else, it will not do anything and just says, okay, the system is already there. And we have seen this yesterday, right? If no change is to be done, the task will appear in green. If some change has been done, it will appear in yellow. And if something has failed, it will appear in red. Okay. Yeah, we have done this. Right. The configuration gets backed up with the respective device names. But this was still using read commands only. Right? We were just doing show run, and then this takes the entire extracts the entire running configuration, which we are storing in a variable. Later, using another task known as copy, we are taking that content out of that variable and writing it back to a file. Yeah. So iOS underscore command is a module which can be used to execute show commands on the devices. Whereas to be able to perform configuration task, right, you need to be in different modes, right? It's not as simple as just running some commands at the command prompt like we do on the Linux devices, right? In Linux devices, we can go to command prompt and issue different commands. Only thing is probably certain commands require escalated privilege, admin privileges, where we change, you do the things with super user privileges. But in on the network devices, it's not this thing, right? There are different prompts, right? There's an enable prompt, and then there's a config prompt, and then if you are doing an interface specific configuration, you get into the interface, right? The prompt changes again to interface. There you'll have to carry out certain tasks and then come back. So it's not that straightforward. So to handle this complexity, they've created another module called as iOS underscore config, right? Which is smart enough to figure out these complexities and go and do whatever required configuration to be done on the devices, right? We can check what is there in the iOS config module using Ansible doc space iOS underscore config. Let's check that. if you see, as we said, this is a module, right? iOS config, iOS underscore config is a module. And we said that modules are nothing but Python files. So this iOS config is nothing but a Python file called as iOS underscore config.py, which is located at this location. Right? Under Python, under Ansible virtual environment, under Python, under site packages, Ansible package, modules, network, iOS underscore config.py. It uses a simple block indent file syntax for segmenting configuration into sections. It essentially means, however you, we saw the show run command, right? It was neatly giving the block indented file syntax. Right? It's going to use the similar kind of syntax, right? Here, these are all given at the same indentation level. And you see this, this is interface loopback 0. The IP address configuration has to be done under the loopback. So it is slightly indented inside. Right? This is interface loopback 0. This IP address configuration has to be done for this loopback. So it is under this with slight indentation. It is not at the same level as this interface loopback 0 statement. So that's what we mean by, that's what we mean, this statement means. Configuration uses a block indent file syntax. So it uses similar kind of syntax because it's more intuitive. How you see that, how you want to see the configuration, the way you give the configuration to Ansible and say configure it. And why we use configuration iOS underscore config is iOS underscore config can figure out those prompts, right? Instead of without worrying which prompt I am in, whether this command will work in this prompt or not, iOS config will take care of all that. Okay. So we will take one example of defining SNMP community strings on a Cisco router. This SNMP community strings are like user ID and password that allow access to the router's statistics. So there are two modes for this SNMP strings, like read only and read write. So if someone has read only permission, they can only get the stats from the router. If someone has read write, they can also update. So I'm saying for this router R1, for general public, give only read-only access. Right? That's what I'm saying for community. At the community level, for public access, make it read-only. If it is specific to something else, then I can give it read-write. And before that, we'll go to R1 and check whether any SNMP configuration, string configuration has already been done. Okay, it's just timeout that has been set. Let's start writing our playbook. Initially, writing playbook might seem a very complex task, but if you just think about what is the command that you're trying to, commands that you're trying to give, and you see that every playbook follows same kind of structure. right? It all starts with a name being given to a playbook. So you give the name, we need to specify on which host this playbook will work. So now we'll just say R1, right? Then we saw that one task always gets executed, which collects a lot of facts, right? Every time we run something. So we'll say, yeah, for now, skip it. We don't need those. Gather underscore facts to no or false. You can use either. So typically, this is how you start any playbook. Gather facts, most of the times we want to disable it. We'll not be using them. Of course, we can disable at the back end, but that's not recommended because we want to have the flexibility to use at any time we want to use some of these variables. So in every playbook, we'll explicitly say, yeah, unless I need it, I'll say, yeah, don't gather facts. Okay, nothing happens. It just takes a little extra time, that's all. Then always my playbooks, this is the basic information. What is the name of your playbook? Which host this will work on? Whether you need facts or not. Once this is done, I have to define tasks. Right? What are the tasks that you're going to do? Task is going to be a list. So I'll have them submit task 1, task 2, and so on. This is how we can, in YAML list get defined. And this is the first item of the list, this is the second item of the list, and so on. Once I have this item, I am defining a task. Right? What is the task? So, config. So for doing this, which is the module I need to use? Right? Till now, we have not come down to actually how we'll go about doing it. So we define name, we defined what are the hosts, we said whether we need the facts or not, and then we started defining the task. We decided this is going to be my first task. To carry out this task, which module is going to help me? Right? This is a config activity for this device R1, which happens to be an iOS device. So I'll use iOS underscore config. Okay. Now iOS config works by taking commands, a list of commands. Okay. So I'll say commands and then start giving different commands one after the other. CCNA server community public R1. Now, normally this will do the job, but let's say you are interested in seeing the output of this command. Because unless we see, we cannot be sure whether this configuration was successful or whether there are any errors. So to be on the safer side, we can see the output. What do we have to do that? At the task level, we have to say, register the result. Register is a keyword, result is not. Result is the I have chosen. So it's a variable in which the result of this operation will be stored. Now it is in this result, but to be able to see it, we'll have to use another task known as debug. This is how your typical playbooks go. Okay. Basic details, tasks, name of the task, which module will help you to achieve the task. Within that module, what are the details that you need to pass? iOS config always will have this commands. Inside this, you'll keep giving these commands in your usual style, how you would give at the terminal. How do we execute our playbook? Ansible -playbook. And if you are executing ad hoc commands, we'll use the executable Ansible. If you are executing playbooks, we'll use the executable Ansible-playbook. Same way, if you want to check the doc, Ansible-doc. And so on. Ansible playbook. Now we need to tell where is the playbook located. It is inside my playbooks and it is known as iOS config. Now, normally here we will have to give the other details like as which user you want to connect, whether you want to be prompted for password or not. All those details normally will come here. But we have already put all those details into our host file at the DEVASC level. So we don't have to provide, these details for each command that we execute on the terminal. So with this, it has all the information which is needed. Simply go to this playbooks folder, take this file, you will have the commands, and using the details which have been specified in the host file, go connect to the device and start executing these commands and print the output. So I'll execute by pressing enter. So the commands that we gave have come here. So the configuration has been done. Now let's try to run the playbook once again and see what happens. Without any changes, simply rerun the playbook. You see here it said previously it was yellow because it made some changes. Now it didn't have any changes to make because the change is already there. So it simply said green. I don't have anything to do. And here it said changed is false because I have not changed anything. And what I am supposed to do, it was already there. And play recap also it shows R1. This is what we call as idempotency. Now you see any number of times I run this playbook will succeed, but it will not cause any ill effect on the router. Right? So if it has something to be done, it will do. If it has nothing to be done, it will not do. And you see, even the things, right? Compared to Python, this is somewhat straightforward, right? In Python, we have to use we have to install NetMiko, use it, connect to the device, and then figure out which prompt you're at using NetMiko commands, and then go and issue this, start issuing these commands by putting them in a list or in a config file. Here we simply say, yeah, I want you to go to R1 and using this module, issue these commands. How you'll do it internally, you figure it out. That's why we call this as a declarative or intent-based. Intent-based. We specify our intent. Our intent is to ensure that this router R1 is configured with these SNMP strings. So you specify this intent in the form of this playbook and then execute it. It will be carried out. Okay. Now we'll take another example. Okay. OSPF configuration, right? OSPF configuration needs to be done inside an interface. Right? So how do we specify that? We simply use ios_config. We say, yes, there are some configuration lines which need to be added, but they should not be entered directly at the main prompt, at the main config prompt. Right? They should be entered inside a specific interface. So you said parents, first issue this command, get inside the interface prompt, then you go and give these lines. Right? So we'll say ios_config. Do not give the commands directly. Instead, the parent command that needs to be given is this. Once that is given, then these child commands need to be given. That's the way we interpret it. Rest all remain the same. Of course, this connection thing we have already specified in the host file, so we don't need to specify it here. Okay. Name, what are the hosts? Get the facts, no tasks. This task. Yes. Fine. module to be used, iOS underscore config. Parents. Under this, what are the lines to be added? Define the area as 0. Define the network. Under the area 0, define OSPF 1 and set the network as point to point. Lines, you'll be specifying multiple lines, so it will be a list, and list always comes like this. So before doing this, let's go and check if any OSPF configuration exists on the device. If there's nothing. Now we can do the rest of the stuff also, like gathering this into an output, printing it, regular stuff, but it's not like really mandatory. So all we need to do is Ansible playbook. You're able to hear me well, right? Somehow it's behaving. Yes. Okay, the configuration has been added. Let's go back and we also get the message here saying that yes, something has been done from somewhere else. No, not this way. It's coming like this. If you actually go to, you see it's slightly indented inside. If you actually print the entire run config and go to the section gigabit Ethernet 01, you'll see that these lines have been entered inside that. Let's verify that. Yeah, here is the 01 description, OSPF configuration. Okay. Now the same thing you can do for, let's say, different devices. There'll be a different module. Like Arista devices, you have Arista EOS command module and config module. FortiGate, you'll have FortiGate specific module, and so on and so forth. But the fundamental concepts remain the same. Okay. Now there is something known as check mode, right? Okay. Network engineers are always scared, right? Okay, if I make some changes, what impact it might have, right? So unless you are very much sure that the change that you are making is not going to have any adverse impact, you don't want to do that. Now, initially, when you're getting started with automation, we are a little clueless, right? But where exactly we are giving these commands, how it is going and getting executed, whether it is it disturbing my existing stuff, whether it is overwriting any of my existing stuff, all such doubts you might have. Because you make slight mistake in the script, it can have some certain adverse impact. So what Ansible has given is, they have given one mode known as check mode, which means a dry run mode. Right? You decide what you want to do. Do not actually do it. Do a dry run. Then ensure that, yes, Ansible clearly spells out this is what it is planning to do. And then once you are sure that, yes, that is what you want Ansible to do, go ahead and run it in normal mode, not in dry run mode, in a normal mode. Right? This dry run mode is also known as check mode. So running something in check mode is simply adding at the end of the command, simply adding minus check. Right? Let's try to do that. So you see, in minus check, it hasn't actually gone, it actually goes to the device, and then it doesn't go to the device. It says, it saw that, yes, we need to go and add some lines in the config. And when I add the lines in the config, its status is going to be changed. So it's coming as yellow and it is showing this. But to be able to see what is the exact change that it will be doing, we need to print the result of this. So let's go to the playbook and print it and then rerun in check mode. Register, result. How do we print this result? Using debug module. Now this result is a variable, so we'll say var result. Which one to debug? What to debug? Right? Debug this variable called as result. That's what we are saying by doing this. Debugging means, okay, show me what exactly it contains. So you see, in this check mode, it has detected that, yes, okay, your playbook is trying to configure OSPF this thing. So these are the commands that I'm going to run. Right? I'll be giving this command interface gigabit 01. Under that, once I enter the interface prompt, I'll be giving these commands. And when the updates are made, these are the updates that are going to be. Right? Since it is running in dry run mode, it doesn't realize that whatever configuration we are asking it to do has already been done. Right? Because in dry run mode, It doesn't actually go to the device and then check. So you run this dry run mode any number of times. It'll keep showing you, yes, this is what I'll be doing, this is what I'll be doing, this is what I'll be doing. So it always comes as changed as yellow. Okay. So when you are not very sure what is the change that is going to have, what are the commands that is going to run, always run the playbook once in a dry mode, ensure that things are fine, things are going to be fine, and then run in normal mode. Now we'll run in normal mode. What to expect? Why did it add? It's not supposed to. This is interesting. What is it changing? Anyway, this will not have any impact because it has already been configured. Probably we are not giving them as individual commands, we are giving slightly differently. Probably that's why it is always getting into the interface mode and then trying to do this. Because in the other one we gave it as commands and then list of commands. So it did not execute. But anyway, this will not have any impact on the this thing. So though it goes and adds them again and again because they've already been added. Yes, commands. Is it item? Okay, so looks like it is idempotent conditionally. While doing certain tasks, this is not behaving in idempotent way. While doing some other tasks, it is doing in an idempotent way, just like how we have seen. Once the SNMP strings have been added, when you try to add them again, it is not doing. But whereas ISPF, OSPF configuration, though we have done it once, again, when we run the same playbook, it seems to be doing it, though the impact is not going to be there on the final device. Yeah, that seems to be the behavior. It seems to be behaving different with different things. in case of managing ACLs, it doesn't seem to be quite important as this case reporting. They have raised a point against this. Anyway, it's not a scope of our discussion. Okay, any questions so far on the Ansible thing?
We'll first go with this workbook, Ravi. Maybe not now, but
okay. Yeah. Anyway, that channel is open. Though we are concluding the classes, right? We can always have that doubt clearing sessions. We can plan that, and I'm available for any queries and helping you guys out.
Sure, Ravi. Thank you.
Next thing topic we'll cover is APIs, because the APIs are like very important. You'll be hearing everywhere, right? Network APIs.
Yeah.
So I thought we'll briefly cover that as well.
Okay.
Now, there is an application. You interact with that application through some interface, right? As human beings, what we do, we open the application like Cisco DevNet. Let's start up my cloud instance. Cisco Devnet samples. So I'm just taking one of the applications, Cisco applications, to demonstrate the power of APIs. The same thing applies for other products as well. I'll take two examples.
Basically, Ravi, any like APIs I never worked, like how to integrate Python with API.
Yes. What were you asking?
Means this API, how we will integrate?
I'll show you.
Okay.
So you're familiar with what are APIs, right?
Sorry?
You're familiar with what are APIs, why we use them, how we work with them?
I worked for Nexus ACI. Okay, so there I saw some automation for creating pools and all.
Okay.
But I don't know like how it was working. I just saw that.
Okay. I'll show you.
This sandbox is a kind of, like EVNG, but this is directly from Cisco. Okay, so you can block your slot and you can use it.
So Cisco guys have created environments for different products of theirs, and they have made them available on a server. So just like we saw, there are different categories, right? Networking, data center, cloud. For all IoT collaboration, for working with all these things, they have set up sample servers. Of course, these sample environments will have certain limited capabilities. So you can create your Cisco account, then log in with them. And there are some which are like always on. For example, I chose the Cisco DevNet, which is always on. So I don't have to reserve. There are some where you have to make a reservation. Accordingly, you can work with that. So this will give you a feel of working with their application without having to set it up on your servers. So this DNS Center is like a orchestration platform. It's like in an organization you have different network devices, right? So this will act like a wrapper on top of this. Will give a nice web UI from where you can monitor different things in your organization. You can create networks. You can create organization. You can create the complete hierarchy. You can create an organization. You can create networks inside an organization. You can create devices under that organization, and then you can provision the devices, saying this device needs to be provisioned to this team for this purpose, and so on. Okay. While this is loading, let's discuss the content. Okay. Let me take another similar example, but this is an open source, right, called as Netbox. Netbox is another open source product. This can be used to do somewhat similar, right? Like you see the hierarchy, you have this organization. So you can add your organization here. Under your organization, you will have different sites, different regions, different site group, different locations, right? And in each, let's say you create a site for your data center is located somewhere in Mumbai. So you create a site for that. There, within your data center, you'll have some racks, right? So, what? Here, yes, we will. This is more like a IPAM software where you can maintain your complete inventory. Whereas DEVASC Center will also help you to manage your devices. Now in this, what we are seeing is, we call it as GUI, graphical user interface. And as human beings, when we want to use this application, what we do, we go to the GUI and we perform this task. For example, I want to create a new site. I'll click on this sites, or I see this this button is there, plus button. I'll say add a new site and provide all the information. What is going to be my site name? Whether it's going to be active or not, to which region it belongs, etc., etc. Of course, these are the primary details that I need to give. I'll say create. So a new site is created. Right? Now, when human beings are doing this is fine. This we interact with the GUI, go ahead and perform our task. But we want to automate this task. That's what we are doing via network automation, right? If you want to automate this task, we should be able to do this either from your Python or from your Ansible or from any other site, right? Any other tool, automation tool. How do you do that? So for this purpose, which means now you're not interacting with this application, you're interacting with this application not as a human being, but as a different application. One application is trying to talk to another application. Like Python is your application. Python is trying to create a site on Netbox. This application to application interaction is provided via API, Application Programmer Interface. API stands for Application Programming Interface. So when you're automating this, typically we use something known as APIs. But how do they look? Yes. I'm showing you sample example. So now for this, whatever you can do on this site via this UI, they have provided a huge layer of APIs to be able to do everything via APIs.
This is what it's figure.
Yeah. Yeah. It depends on the application. Now this application has these features. Different application might have different things. Yeah, we have like now. Oh, they have refreshed the instance, so the devices are gone. Okay, they are there. So I see this in the sandbox which they have created, there are 34 sites, 4 network devices. Let's click on this network devices. These devices are unassigned. It is loading them still. Right. Now, whatever we are doing from UI, right, we'll be able to do. So these are my network devices, and they are like currently unreachable. And these sandboxes, right? Typically, they'll give you only read permissions. So you'll be able to check out the data. You'll not be able to add new devices because it is their server. Right? So most of the times you'll have kind of read-only access. You can play around. You can check different devices. But since this being a open source application, I can also create data. Now, how this APIs will be made available is, as I said, like whatever, first they will decide which of which functionality need to be exposed via APIs. Means which functionality should be automatable. Netbox guys decided we'll expose everything as APIs. Cisco guys decided, okay, we'll expose few functionalities as APIs. Quite a few functionalities they have exposed. Now, this Swagger is a kind of tool for documenting, for providing documentation for your APIs. What all APIs that your tool is exposing, you can create a document like this. Right? Now, in Netbox, you see, I have circuits under sites, under racks. I have somewhere I'll have circuits. Yeah, these circuits. So what you can do with these circuits, all the methods are given here. So this is just a documentation. I'll come to this part. But the point I'm trying to drive home is this. So the concept of APIs is, APIs are like programs which can be called from your program. You're writing a program, Python program. You want to programmatically do something. You call an API and get the work done. Right? Let's say in Cisco DevNet, you want to check how many devices are there and what are the device names. As a human being, what you would do, you would go to browser, you will give the Cisco DevNet link, log in, and then do all that. But I'm asking my program to do it. I'm asking my Python code to do it. How will it do? There is an API for getting these details, which is exposed by Cisco guys. So I'll take that API, give it to my Python, and then use this API and get the required details. So these APIs are like application programming interfaces. They provide an interface between two different applications. Right? If you want to understand them better, these are some examples. You open any website like Money Control or any finance related stuff, you will see those stocks ticking, right? Stock markets. Now, does that mean that Money Control guys have implemented this functionality? No, they borrow it from the stock exchange providers. The stock exchange providers expose their functionality, using which we can get the stock tickers continuously, the changing values of the stocks. We can use that API, which exposes this functionality, put it in our code, put it in our website. So our website will start showing that. Right? So that is one example of API. If you want to have another better example, right? Now you will be using these apps like Zomato, Swiggy, Ola, Uber. Whenever you open them, right? When you order something or when you book a cab, what you see? You see a map where it shows you where the driver is or where the delivery executive is, whether he has picked up your order or not. All this is being shown on top of a map. Now, Ola, Uber, Swiggy, Zomato guys, they have not developed this, right? This map is developed by Google, Bing, MapMyIndia, these guys, who are specialists in building maps. But these guys need to use the map. So they said, okay, I want to use the map. You give me an API for my application to use your application. So they expose their map via an API. These guys simply use that API, integrate the map into their application, and then they can start using it. That is an example of APIs. There are different sub APIs called as REST and non-REST APIs, but we'll be mostly seeing something called as REST APIs. You don't have to worry about what are REST APIs. They're simply like you can work with them as if you work with web pages. That's all. Now, just because I'm using an API doesn't give me an access to, should not be giving me an access to your application directly, right? Like this DRAC guy has exposed an API using which I can check what are the devices which are available, right? But anybody now to be able to see these APIs from UI, I'll have to log in. I'll have to enter my username, password, login. Only then I'm able to see it. So when I'm going through API also, there is a security mechanism, right? You should be an authenticated user. You should have been an authorized user to be able to extract details via APIs, right? So the point to note here is, just because APIs expose the functionality doesn't mean they are insecure. They have security aspects taken care of. Which means if you cannot simply pick an API and start using it. First, you should do something else. Either enter your username, password, or generate some secure token, pass the token. Only then you will get secure entry into secure permission to access data via APIs. Now, where these APIs are provided is, there's a tool called as Postman, right, which is a very popular tool for working with APIs. Here I can go and I can search for, you see, so some guy, right, the developers at Cisco have created this API layer and they have made it available as collections. So I'll click this, it will come and sit in my local tool, right, in this tool here under these APIs. So they have categorized these APIs as authentication, network devices, tags, PNP, assurance, policy, SWIN, etc., etc. Right? They have categorized their APIs like this. You see similar categorization you will see in case of Netbox also. To work with circuits, DCIM, etc., etc. So basically this classification is nothing but whatever functionality you see on UI, the same functionality they try to offer via these APIs. So as I said, right, first I need to let me show you with this. Okay. From UI, we saw that we created a site. Now, how can you do the same thing via an API? So we have to go to API documentation. It looks either like this or like this, and then see where you have this site related APIs. So when I search for sites, it brought me to these, and they offer this different things that you can do with the sites in the form of some methods, right? If you go to UI, what can you do with these sites? You can create a new site, you can edit an existing site, or you can delete a site. That's what typically you'll be able to do with different objects, right? Networks, you can create a network, you can edit a network, you can delete a network, right? Device, network device. You can add a new device, you can update its details, you can remove it, right? So those the same operations that they are provided via APIs. Get means get the details of the site. Post means create the site by giving some details. Put or patch means update the device. Delete is delete the device or site or whatever. So get, post, put, patch, and delete. These are the typical methods that they provide via any API, because these are typically the things that you are doing from UI. You are creating objects, you are modifying them, you are deleting them. Same functionality that they are provided. Get is for reading, post is for creating, put and patch is for updating, delete is for deleting. Now here I want to create a site, right? So I want to create a site. I need something known as URL, because API is nothing but API will have something known as an endpoint where the request goes. So this is my base URL. And inside this, PCIM sites. You see, this is my API URL. Now from UI, let me access sites, right? I am in sites. Copy this. You see, they look exactly the same. HTTPS, demo.netbox.dev, TCM sites, only changes this extra word API here. That's what distinguishes between a normal web page and API. Of course, this is not again applicable for all applications, because different people expose their APIs in different ways. Some people introduce the version here. Okay. And the Cisco guys have decided to expose them like this. Right. You see the UI URL from this website, HTTPS, your server name /DNA/provide provision devices inventory. Okay. Whereas your API URL looks like HTTPS, the server name /DNA/intent/API. You see this thing here, intent API v1. This is extra. and network device. So this is the URL which will help you to interact with the API endpoint. Okay. So we need to find this URL. Where we'll get this from is API documentation. Now what do you do once we get this URL? We take this and go to tools like Postman. And we have put it here. Now this is my base URL. If I apply get method on this URL, I'll be able to get devices. If I apply post method, I'll be able to create devices and so on. Right? Again, it's not that simple. In the documentation, they would have given, okay, if you want to create a device via API, what are the minimum details that you need to provide? Okay. So that is how APIs work. This is my API endpoint, which will help me to fetch the devices. So I'll give the API here. I'll choose the method, what I want to do with it. I'll say send request. So it is sending request to this server. Okay. Obviously, since I have not logged in, simply I have taken some random URL and I was asking it to get details. If it had gotten the details, then certainly this server is not secure, right? So it said, no, you are not authorized. 401 is like a error code which you get when you work with something known as HTTP on the web pages. Right? It says unauthorized. The message we get is something expired. Right? There's a concept of token, which is like a password, encrypted password. It has expired. So first I need another API which will generate this token. Right? And the token has to be sent whenever you are sending. The token has to be sent whenever you are sending the request in something as header, HTTP header. Whenever we are sending this request, we need to send that secret password which you have already got from the server. So that is a way of authenticating yourself. Just like how in UI, how you enter your username, password, and then say, okay, now I'm logged in, show me the details. This is a way you do things with APIs. Again, this authentication mechanism differs from different application. DNAC guys have chosen to implement it this way. So to authenticate itself, they have provided one API where we need to provide basic authorization details in a basic username password encrypted format. Once you give that basic details and then send it to this, he will send you back a big string, encrypted string called as token, which is supposed to be very highly secure. Now I took this token whenever I am sending the other request, for example, like this get device list, get devices. Right? I am sending that token here. You see, when I highlight this, I see this entire token thing. Okay. So that is my way of authenticating. Now I have authenticated, I'll say send. Now I get proper response. See, I got a JSON response. It is saying there are multiple devices in it because there's a list. First device is Cisco iOS software Catalyst L3 switch of this. And its host name is leaf1.abc.inc. You go to UI, you will see same details. leaf1.abc.inc. Click on this. It is a Cisco Catalyst 9300 switch, as we have seen from our API response. Right? It's a Catalyst LP switch. 9300 switch. You see this, you get complete information. Now this is more in a shape on which my Python program can work, right? It can use this device information and use it programmatically. It can find out what is the status, what is the last status update time, and so on. Okay. Now your next question is, okay, how do I use this in Python? Now this Postman is a very nice tool. It provides you, what the API, I have invoked it from Postman UI, but that's not my intention. I should somehow get the code so that I can put it in my Python program. So these guys have thought about this and they have provided a nice feature called as code. You click here, whatever we have done now can be converted into many programming languages, as you can see here. C, C#, Java, JavaScript, Node, PHP, Python. In Python, specifically, there are two ways you can invoke APIs, using the request module or using HTTP client. Request is more popular, so we'll say request. So you see, it has generated Python code. It's just about 12 lines of code, of which majority of the thing is your token. Copy this and put it in your Python file. So it is that simple to invoke API from Python. You simply say import request. Request is a module which will help you to send these API requests. Right? You import it, import request. Then you define your URL in a variable, the endpoint, which we have used from Postman, in a URL. And then payload is like body. Have we sent any, does this API require any body to be sent? Body means the data that you will be sending. Now, what we have used is a get method. Get method doesn't need any data to be sent. Whereas if you are trying to create a new device, that would require data. In that case, you'll have to send something in payload. That also Postman will tell you. You don't have to worry about it. And we saw every API needs to have secure details to be sent. So this token has to be sent along with the request whenever your Python is sending this request. Right? So you'll say request, the module which we have imported, dot request, send the request. Using this module, send the request to where? To this URL. With this header information, with this token information, with this data. In this case, data is not there, but suppose if data was there, send this data. And the method to invoke there is get. Whatever we have done Postman has been captured into code. Once this happens, you print the text part from the response. We saw the response was a big JSON object, right? So we can print the text from it. Let's execute this from Python. unable to get local issue certificate. SSL. Okay. Should say verify is false. Yeah. Now you see I got my data. Response, Cisco software, blah, 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 blah. So from my Python program, I have spoken to DNA Center application, got its device details in a JSON string. This was a JSON data. I can process it and extract different details from it. Okay. Now get device by IP. In get devices, I'll have IP addresses at 10.10.20.81 management IP address of this device. So 10.10.20.81. I'm saying specifically get fetched here. It has fetched all the devices. So you'll see a big response. But you want only a specific device by its IP. You specify its IP and then say send. Now you get only one device. Okay. Within the device, within the DNAC center, get all the interfaces. So you got all the interfaces. It's a huge list with close to 7,000 lines. So the 4 devices have this much of information. Assurance. Okay, that is the basic concept of APIs. Postman is a tool which can be used to invoke APIs. But before that, we have to get the API documentation from the developers, which is available either. Now Cisco guys have not given this thing; they have directly exposed this, or these guys have decided to give the documentation like this. Okay. Of course, it's little tricky thing. It will take some time for you to get used to it. But I mean, once there is a use case for that, right? Now my use case is, okay, get these details from Python and then extract its description. Right? I don't want this entire thing to be printed. I want only the description to be printed. So I saw that, yes, it is in whatever text I got inside this, there's a response. From the response, I should extract description. I'll say instead of this response, I'll say this. That was text. This is JSON, means it will fetch the JSON object. Okay, I got my JSON. From this, I'll extract. I'll store in my available JSON data. From this JSON data dot results. That's the first element, right? Response. So just data dot response. For the response. From this, we have to get, this is a list of elements. So I have to get 0th element first. Then from the 0th element, I need to get the description. I'm just breaking down my dictionary or JSON like data to extract different details from it. Now it has printed only this, the description. So some warnings are there which we can get rid of by doing some things in the, taking some action in the Python. That is fine, but we are getting the data. Now this is just a use case extract data. But if required, if you have the proper permissions to be able to change some configuration, add some details to your Cisco DevNet, you will be able to do even that. Okay.
Recording stopped.
I'll be